You're going to start today on page 33 in your books, doing section 1.5, absolute value equations. The first example we're going to do is just a basic absolute value equation. The first thing I want to point out, though, is this key concept here, that you have the absolute value of x equals x. There's two scenarios that can happen. What's inside can equal x, as long as that is greater than or equal to 0, right here. What's inside can equal negative x, because remember, absolute value is the distance away from 0. So we are literally saying that what is inside is x away from 0. It could be to the left of 0 or to the right of 0 on the number line. So when we are setting up these equations, if we look at example 1, what is inside here, 2y minus 4, could equal 12, but it could also equal negative 12 because the absolute value of negative 12 is also 12. So when you are solving these, you are going to set up two equations. You are going to take what is inside, 2y minus 4, and set that equal to 12. And then you are going to look at the other scenario, what's inside, 2y minus 4, and that could equal negative 12, because the absolute value of 12 is 12, and the absolute value of negative 12 is 12. Once you set up these two equations, then you are just going to solve. You're going to add 4 to both sides here. You will get 2y equals 16. And then you will divide by 2. And you will get y equals 8. That's one of your answers. And then you're going to do the same thing to the other equation. You're going to add 4 to both sides. You will get 2y equals negative 8. And then divide by that 2, and you will get y equals negative 4. So your two answers here are 8 and negative 4. Those are your two options. And you can go back and plug them in, and you will see that if you plug in an 8, you will have 2 times 8 is 16 minus 4 is 12. The absolute value of 12 is 12. Plug in a negative 4. 2 times negative 4 is negative 8. Negative 8 minus 4 is negative 12. And the absolute value of negative 12 is positive 12. So go ahead and pause the video here and take a few minutes to work out this check understanding number 1, and then continue on the video when you're finished to check your work. All right, let's look at this one together. We have the absolute value of 3x plus 2 equals 7. So we're going to take what is inside, and we are going to set that equal to 7. And we're going to take what is inside, and we're going to set that equal to negative 7. And then we are going to solve these individually. Subtract the 2 from both sides. You will get 3x equals 5. Divide both sides by 3. One of your answers will be 5/3. We'll do the same thing over here. Subtract the 2. You will get 3x equals negative 9. Then divide by that 3. And your other answer here will be negative 3. So your final answers are 5/3 and negative 3. The next thing we're going to look at is what happens when you have things outside of the absolute value. When we're doing absolute values, we want the absolute value by itself before we solve. So for this particular one, we have 3 times the absolute value of 4w minus 1 minus 5 equals 10. So what we need to do before we set up our two equations is we need to get this absolute value by itself. To do that, we are going to do exactly what we would do algebraically to get something by itself. For this one, we will add the 5 to both sides. That leaves us 3 times the absolute value of 4w minus 1 equals 15. And then we're going to divide by that 3. And we'll get the absolute value of 4w minus 1 equals 5. Now that we have it by itself, then we can set up the two equations. Not until this point do we set up two equations. So now we're going to set up the two equations of what's inside. What's inside 4w minus 1 can equal 5, and what is inside 4w minus 1 could equal negative 5. And now we're going to solve these the way that we would with a regular problem. Add the 1, 4w equals 6, divide by 4. One of my answers will be w equals 3/2 when I reduce. Same thing for this one. Add the 1 to both sides. 4w equals negative 4. And then we can divide both sides by 4. So my other answer here will be negative 1. And again, you can check these answers by plugging them back into your original equation up here. So go ahead and pause the video here and work out check understanding number 2. When you're finished, you can resume the video and check your work. All right, so let's look at this one together. The problem is 2 times the absolute value of 3x minus 1 plus 5 equals 33. We want to subtract that 5 first. We will get 2 times the absolute value of 3x minus 1 equals 28. And then we can divide by that 2. We get the absolute value of 3x minus 1 equals 14. Now we are ready to set up the two equations. What's inside 3x minus 1 can equal 14. What's inside can also equal negative 14. And then we are going to solve these. Add 1 to both sides. 3x equals 15. Divide by 3. One of my answers is x equals 5. Same thing for the second one. Add your 1. 3x equals negative 13. Divide by that 3. My other answer will be x equals negative 13 over 3. And those should be your answers for this one. Now the last thing that we're going to do for absolute value equations is we are going to check for what's called extraneous solutions. Extraneous solutions are solutions that you will get when you solve, but when you plug them back in, they will not work for your equation. And so really the time that you're going to see this happen the most is when you have an x outside of the absolute value, because there are times when you could plug something back in and your absolute value doesn't equal something that is positive, which is not something that can happen. So we are going to do this exactly the same way. We want to make sure that the absolute value is by itself on one side of the equation, and then we're going to set it up with the positive and negative of this right side. So let's look at how we do that first. We're going to take what's inside, 2x plus 5, and we're going to make it equal to just what it has already in the original equation, 3x plus 4. And then we are going to take the inside again, 2x plus 5, and we are going to make it equal to the opposite of what it had in the original equation. So we put that negative on the outside of that group for this second one. And then we're going to solve these. So for this left one, we are just going to get all of our x's to one side. So subtract that 2x, we'll get 5 equals x plus 4, and then move my numbers to the other side, and we will get x equals 1. That is one of my options here, x equals 1. Let's look at the right side here. For this one, we need to distribute this negative. So we have 2x plus 5 here, and now we have negative 3x minus 4 on this side. And then we're going to solve this one. Get our variables to one side. That gives us 5x plus 5 equals negative 4. And then we are going to subtract my numbers over. 5x equals 9. And of course, divide by 5. We are going to get x equals negative 9/5. All right. And so these are my two answers that I get when I just solve the equation. But because I have a variable on the outside, it's very important that I go back and check this. And so to check it, I'm simply going to plug them in. So I'm going to check my first one. I will check this, and I will say 2 times 1 plus 5 equals 3 times 1 plus 4. So I have the absolute value of 2 plus 5, that's 7, equals 3 plus 4, which is 7. That is true. So I know that this is definitely an answer. It works. Let's look at the other one. We're going to plug that one in. So we're going to check this guy. We're going to say the absolute value of 2 times negative 9/5 plus 5 equals 3. I'm running out of room here. So 3 times negative 9/5 plus 4. All right, so on this side, we'll say 2 times negative 9/5. Well, that's negative 18/5 plus 5 equals 3 times negative 9/5 is negative 27/5 plus 4. And we do need a common denominator here. I'm going to shift this up a little. So my common denominator here is 5. So I get the absolute value of negative 18/5 plus, to get a common denominator, 5 is 25/5. And then we have negative 27/5. Common denominator here, 20/5. That is 4. And then I just need to solve it. The absolute value, negative 18 plus 25, is negative 7/5 equals negative 27 plus 20. That's negative 7/5. Well, that seems to be the same answer, except we're saying the absolute value of negative 7/5 equals negative 7/5. That is not true. The absolute value of negative 7/5 is positive 7/5, which means this answer does not work. This is not a solution. So the only solution I have here is x equals 1. I will not have two solutions for this particular one. That is an extraneous solution. Negative 9/5 is extraneous. It is not an actual solution to this particular problem. So go ahead and pause the video here and try check understanding number 3. And when you're finished, continue with the video and check your work. All right, let's look at this one together. The equation that they have here is the absolute value of 2x plus 3 equals 3x plus 2. So we are going to set up two equations because my absolute value is already by itself. The first one will be 2x plus 3 equals exactly what they gave us, 3x plus 2. The second one will be what's inside, 2x plus 3 equals the negation of what they gave us, 3x plus 2. So we'll solve this left one first, get my variables to one side, get my numbers to the other side. So I get 1 equals x. So one of my solutions is 1. And then we're going to look at the right-hand side. We need to distribute this negative 1. So we get 2x plus 3 equals negative 3x minus 2. Get my variables to one side. And then get my numbers to the other side. So my other answer that I'm going to get here is x equals negative 1. And then I need to check them. So I'm going to check this one first. I get the absolute value of 2 times 1 plus 3 equals 3 times 1 plus 2. Get the absolute value of 5 equals 5. That is true. This is a solution. I'm going to check this one. I get absolute value of 2 times negative 1 plus 3 equals 3 times negative 1 plus 2. Negative 2 plus 3 is 1. 3 times negative 1 is negative 3 plus 2 is negative 1. The absolute value of 1 does not equal negative 1. This is not a solution, which means 1 is my only solution. Negative 1 is extraneous. And I will say, with these equations, you can have both answers can work, both answers can be extraneous, or one answer could be extraneous. It is not always one works and one is extraneous. So you can have different scenarios. You can have no solutions because they are both extraneous. You can have 2 solutions because they both work, or you could have one solution because only one of them works and the other one does not work. So just make sure you check your work on these. All right, the next thing we're going to look at, we're going to start on page 35, and we are going to do absolute value inequalities. Absolute value inequalities. And so what happens here is that you create these graphs of solutions, and you can either have an absolute value that is greater than your answer, which is what we're going to look at first, or you can have an absolute value that is less than your answer. And these actually form compound inequalities, all right? Compound inequalities. And so when you have an absolute value that is greater than, you are going to have an or situation where it doesn't matter if they cross over. It can go any direction, and typically these will go opposite directions, all right? Typically they will. So when you have greater than or equal to, then you will have an or situation, and they typically go opposite directions, and it's everything on the graph, all right? You are going to treat this just like an equation. You are going to set up 2 of them, and you are going to change your sign, but you are also going to change your inequality here. So for this one, what's inside 3x plus 6 could be greater than or equal to 12. But what is inside 3x plus 6 could be less than or equal to negative 12. Why does this happen? Well, let's look at this up here. They have the absolute value of x is greater than 3. Well, that is true for all of my numbers bigger than 3. Let's say 4. The absolute value of 4 is definitely bigger than 3. But then let's look on this side of the graph, less than negative 3. The absolute value of negative 4 is greater than 3. That is also true. And so what's inside could be bigger than 3, but it could also be less than negative 3. And when you plug it back into the absolute value, it makes the statement true. And so that is why we are setting up these 2 inequalities. What's inside can be bigger than that 12, or it could be less than the negative 12, because when we plug it back in, it's going to make this true. Once you set up these inequalities, you set up one exactly the way it looks, then you flip the greater than, less than, and you change the sign. Then you just solve these like you would any inequality. So that's what we're going to do. We have set them up, and now we're just going to solve them. Subtract 6 from both sides. 3x is greater than or equal to 6. Divide by 3. X is greater than or equal to 2. That's one of my inequalities. Same thing over here. Subtract 6. 3x is less than or equal to negative 18. Divide by 3. And we get or x is less than or equal to negative 6. Those are both true statements if I were to plug them back in. So I can graph them. X is greater than or equal to 2, or equal to means I'm going to do a closed circle, and then I'm going to shade everything bigger than 2. x is less than or equal to negative 6. Closed circle on negative 6. Everything to the left less than negative 6. So you work these very similar. You say what is inside exactly the way it gave it to you, greater than or equal to 12. Then what's inside, flip your greater than less than, change this to the opposite. It was 12, we're going to make it negative 12. And then just solve those two inequalities like you would. All right, go ahead and pause the video here. Do check understanding number 4, and when you're finished, continue with the video and check your work. All right, let's look at this one together. We have the absolute value of 2x minus 3 is greater than 7. We're going to set it up exactly the way it is. What's inside? 2x minus 3 is greater than 7. Then we are going to set it up one more time. 2x minus 3, change my greater than less than, and negate what it had over here. Then we're just going to solve these. You add your 3, 2x is greater than 10, divide by 2, I get x is greater than 5. Do the same thing over here. Add 3, 2x is less than negative 4, divide by 2, and I get x is less than negative 2. This is OR, so I'm going to graph them individually. I'm going to say open circle on 5 and greater than. It does not include 5, so that's why I do an open circle. And then negative 2, open circle here, and less than. So everything to the left of negative 2. And so that is what your answer should have looked like for this particular problem. Okay, now we're going to look at one that is less than. When you have the absolute value is less than a number, you're going to create an and problem, And so that's what this key concept is telling us here. It's saying if I get my absolute value completely by itself and it is greater than my number, I am going to create an OR problem. And when I get my absolute value completely by itself and it is less than, then I create this and problem where my answer should overlap. All right? The key is to get it by itself first, and you have to follow the rules of absolute or inequalities when you are getting it by itself. So for this one, my absolute value is not by itself, so I need to get it by itself first. I have 3 times the absolute value of 2x plus 6 minus 9 is less than 15. I need to get the absolute value by itself, so I'm going to add my 9 to both sides. I have 3 times the absolute value of 2x plus 6 is less than 24. Then I'm going to divide by that 3. And I have the absolute value of 2x plus 6 is less than 8. Now my absolute value is by itself. It is less than, so I'm going to have an and situation where they need to cross over. So I'm going to set up 2 inequalities. The first one is going to look just like this without my absolute value. So what's inside 2x plus 6 is less than 8. It is an and problem. So my second one will be 2x plus 6. I need to change the inequality, so flip it to greater than, and I need to change my negative here. So it was positive 8. I need to make it negative 8. And now that I've done that, I can solve these individually. Subtract my 6. I have 2x is less than 2. And then divide by 2. I get x is less than 1. Do the same thing on the other side. Subtract my 6. 2x is greater than negative 14. Divide by 2. X is greater than negative 7. This is an and problem. All right? So I go to my x is less than 1, open circle on 1, everything to the left. X is greater than -7, open circle on -7, everything to the right. And you can see they cross over on that in between. So this is my answer. X is less than 1, X is greater than -7, and my graph should look like this, everything in between. It can also be written with your lowest number, -7. Remember, -7 is smaller here, so -7 is smaller than X, and X is smaller than 1. So it can be written more concisely like that. So go ahead and pause the video here and work out this particular problem, and then when you're finished, continue with the video and check your work. All right, let's look at this one together. We have the absolute value of 5z plus 3 minus 7 is less than 34. We need to get this by itself first, so I'm going to add 7 to both sides. I will get the absolute value of 5z plus 3 is less than 41. So now that it is by itself, I can see this is a less than. This is going to be an and problem. So I have 5z plus 3 is less than 41, and 5z plus 3 is greater than -41. Then I'm just going to solve these. Subtract my 3. I get 5z is less than 38. Then I am going to divide by 5. And I will get z is less than 38/5. When you are graphing, sometimes it's easier to put it as an improper fraction. So in this case, z is less than 7 3/5, just so you can see where you're going to graph it. You're then going to solve the other side. Subtract 3 from both sides. You get 5z is greater than -44. Divide by 5, and you get z is greater than -44/5. Again, maybe easier to write it as an improper fraction. Z is greater than -8 4/5. So I'm going to take this and I'm going to do an open circle at 7 3/5, which is about right here, and everything to the left of that. And then an open circle on -8 4/5, which is about right here, and everything to the right. And you can see that they overlap on this part that is in between those.